Hey, welcome. Today, we're going to pull back the curtain on language itself and look at a totally different way of understanding how sentences actually work. It's an approach that sees grammar not as a bunch of boring rules, but as this beautiful, self-contained system of logic.
So think back to English class, right? You were probably taught that grammar is just this long list of complicated rules that you just have to memorize. But what if there's a much more elegant, a much more powerful way to look at it all? A way where the grammar is already hidden inside the words themselves. Okay, so let's dive into our first big idea. To really get this new approach, you kind of have to flip your whole way of thinking. We're going to take that big, heavy grammar rulebook and we're going to hide it where no one ever thought to look. So on the left, you see traditional grammar. You've probably seen these complicated tree diagrams where all the rules are coming from the outside and being forced onto the sentence. But on the right, categorical grammar does something pretty radical. It says the instructions for building a sentence aren't in some external rulebook. They're packed inside each and every word. This right here is the core principle. It's this idea of lexicalization. So just imagine that instead of a separate book of grammar rules, all of those rules are built right into the dictionary entry for every single word. The logic becomes universal. It's only the dictionary that changes from language to language. Okay, so if the rules are inside the words, what does that actually look like? Well, this brings us to the absolute engine of categorical grammar. This idea of seeing words not as just static labels, but as active little processes, constantly looking for partners to connect with. First up, we've got our basic building blocks. We call them atomic types. You can think of these as words or expressions that are already whole. They don't need anything else to be complete. A proper noun, like John, is a perfect example. We'll just assign it the type N. And our end goal, a complete sentence, we'll call that type S. But this is where it really gets interesting. We also have what are called complex types. These are the incomplete words. They're functions. They're like little puzzle pieces with a very specific shape, and they're actively searching for another piece to connect with to build something new. They're literally defined by what they're looking for. And this slash notation is the key. It tells a word which direction to look. Think of the slash like an arrow. With a backward slash, B/A, the word is basically shouting, hey, I need something of type B over here to my left. And once it finds it, boom, they combine and become a new thing of type A. A forward slash, A/B, just means it's looking for that B on its right. This simple little directional cue, it's the key to the entire system. All right, so we've got our complete pieces and our searching pieces. Let's put them on the board and see what happens. You're about to watch a simple sentence like John walks solve itself like a beautiful little math problem. It's really cool. Let's walk through this with John walks. We know John is a complete noun, so it's type N. The verb walks, well, that's incomplete. Its type is N/S, which means it is actively searching for a noun, N, to its left to make a sentence, S. And would you look at that? John is right there, the perfect fit. So the N from John satisfies the N/ from walks. They just snap together, the types cancel each other out, and what are we left with? We're left with S, a proven sentence. And just like that, the calculation is done. See? We didn't need a crazy tree diagram. We just let the functions that were already encoded in the words do their thing. The sentence isn't just correct, it's been proven to be grammatical through this simple, elegant process of cancellation. Okay, so this is a really cool party trick, but what does it all mean? What are the deeper implications? In this next section, we're going to see why thinking about syntax this way is so incredibly powerful. We're moving from a simple calculation to a formal logical proof. The huge leap forward here came from a linguist and mathematician named Joakim Lambeck. He's the one who formalized this system into what's called a syntactic calculus. So in his framework, checking if a sentence is grammatical is literally the same thing as proving a theorem in logic. The words are your starting points, your axioms, and the combination rules are your rules of inference. And when you start treating grammar like logic, you get some absolutely incredible benefits. First, like we said, you get this universality. The logic is the same everywhere, just the dictionaries are different. But even more importantly, you create this beautiful, transparent bridge between a sentence's structure and its actual meaning. And finally, you can analyze language with the same mathematical rigor we usually save for computer programs. In fact, this link between the structure and the meaning is so direct, it actually has a name, the Curry-Howard correspondence. Now, that sounds complicated, but all you really need to know is that it means our little grammatical proof, that simple cancellation we just did, it doesn't just tell us the sentence is valid. It simultaneously gives us a direct recipe for its meaning. So the grammar doesn't just build the sentence, it builds the meaning at the exact same time. Now, you might be thinking, okay, this is a clever idea, but it sounds kind of old. But as we're about to see, this is not just some historical curiosity. It is the vibrant foundation for a ton of modern linguistic research. You see, Lambeck's original system was just the beginning. Researchers have since built even more powerful versions to handle the really tricky parts of language. For instance, things like multimodal grammars can handle languages with really flexible word order. Others can figure out the meaning of sentences where words that belong together are super far apart, like in, which book did you say that you liked? Each one of these modern systems builds on that same fundamental idea. The logic is inside the words. So what's the big takeaway here? Remember that long list of grammar rules from school? Well, maybe we don't need it. Grammar isn't some messy collection of arbitrary rules that we force onto sentences. It's an elegant, predictable, logical system that just emerges directly from the words themselves. And that leaves us with one last kind of mind-bending question. We've just uncovered this hidden mathematical logic humming away right beneath the surface of our everyday sentences. And it really makes you wonder, what other complex, seemingly chaotic systems in our world might also have a simple, elegant logic just waiting for us to find it?